we're still in 7-1. My goal today is to complete 7-1. So here is basically the rule, the formula for calculating the integration of a product, f of x, g of x. It's f of x, capital G of x, subtract f dashed of x, capital G of x. Here is our first function. It has some limits of integration, which are really no big deal. Here are the two pieces. Which one's going to be f of x?
Sine.
Okay. One of the rules that you use for who to decide for f and g is that.
Oh, sorry. I was thinking it was sine of t. T squared.
T squared. Perfect. I was going to say one of the rules is pick your f of x to be the one that gets simpler. So if you differentiate it, does it get smaller? And yes, it does. So in this particular case, we are going to get f of x, which is this guy. The integral of sine 2t. Now we showed you yesterday the shortcut for that, right? So here it goes. If you integrate the sine of 2t, you get negative the cosine of 2t. But you also get a half because of that too. So that's what that guy is. So there's those two get multiplied. Then you take away the derivative of this guy, which is 2t, and the integral again, which is the same guy that we wrote down a minute ago, dt. I'll tidy this fella up. Those two cancel out. Those two negatives actually cancel out, so it's now a plus. And I'm left with t, the cosine of 2t, dt. Now, if you notice that the integral started with a t squared, and it's now changed to a different integral with a t. And that's what I mean when I say it gets simpler, right? It gets smaller. Continuing then. Who shall I pick as the f of t this time?
We pick t.
Yeah. Is it not you pick the same guy that you picked the last time? So if you've decided it's going to be a power that you use for the f, you keep picking that power until things are finished. And this should finish up shortly. So we've got this guy. This fella's going to be f of t, which is t. Integrate the cosine of 2t, you get the sine of 2t times a half. Subtract. Derivative of that is 1. Integral of that is 1/2 the sine of 2t. So now I have this guy. Add this guy. Take away this guy. And one last thing to do, and we're finished. If you do these questions, typically what happens is that the integral just reduces and reduces until you reach a point where you actually know what the answer is. And I know what the answer to this integral is. It is, if you integrate a sine, you get a negative cosine. Two negatives make it a plus. So I get a cosine of 2t with another a half. And I just realized there's a half here. So that should be a quarter. Now, what's a little bit different? The integral is going to go from 0 to 4 pi. Which means you're going to plug in some stuff, take away, plug in some stuff, and you're going to get your answer. I bet I'm skipping by. Right, so you plug in 4 pi here, 4 pi here, 4 pi here, get the answer. Then you'd plug in 0 here, 0 here, and 0 here and get the answer. I would go with that question. It's a pretty much a run-of-the-mill integration by parts question. Things are good. Well, that's one of the ones we got to do today. Let's move on to the next one. Who are we going to choose this time?
5 for F.
Agreed. Why'd you pick it?
Because
Made you decide?
can derive that easily.
Yeah, and you're going to have this guy, and this guy is not your friend, essentially, right? So what's that going to get us? Well, let's see. Oh, well, let's pause here a minute. Can you integrate inverse tan of x? Can you find the antiderivative of inverse tan of x?
No.
No.
No. If you tried to use this combination, right, wouldn't the next line be 5, the integral of the inverse tan? And you see how that would immediately go, oh. So if one direction doesn't work, don't you just watch places? I mean, you only have 2 choices. So if one isn't going to make it, that's the other one. So this is going to be my F, right? And this is going to be my G. So F is going to be inverse tan. And G is going to be the integral of 5, which is what? Just basically 5x. Take away. We do know how to differentiate the inverse tan. And you may be a bit rusty on it, but it does exist. Can anybody remember what the derivative of an inverse tan is?
1 over 1 plus x squared.
That's the guy. Times 5x dx. So I like the x's at the front, so that's all I'm doing here. And I'm not really doing that much with this one. We're just making it look slightly pretty. And we're at this point. This is done, right? This is an answer. This is part of the answer anyway. This integral is our next job. Do not get caught up with the integration by parts only has integration by parts. And don't try and keep doing integration by parts. It won't work now. This guy here is actually a different technique. Do you recognize what method we would use to integrate this fraction?
U sub.
So use that as your U sub. So what we now have is 5x inverse tan of x. Take away, let's see, I have a 5x over a u times a 1 over 2x dx. That becomes 5x inverse tan of x. The x's cancel, and essentially I have 5 halves, 1 over u, but that should be du. Du. Me personally, I find it easier, at least sometimes, to pull out this weird constant, otherwise it gets in the way of this. Right. Now, can you see that this is doable, right? What is the integral of 1 over u?
ln u.
And instead of writing ln u, can I just turn it back into that guy and call it good? Are we cool with this question? Right. The reason I chose this next one is that before we start worrying about F and G, I think it's very helpful to think about a different way of writing this. This, I guess for all intents and purposes, this is a fraction, which it is. But written in that form, it doesn't really lend itself to this rule. So I'm going to look at this x cubed in the bottom. And I'm going to write it like that. Are you comfortable about the transition from this form to that form? And the reason I need to do this is, doesn't this process require two things multiplied? Not two things divided, but two things multiplied. So that had to be done. Secondly, if I'm going to differentiate or integrate that, doesn't it need to be a power of x so I can do it? You can't leave it in the bottom, that's not going to work. Okay, so it's decision time. One of these two guys is f of x. Who's it going to be?
F should be ln x squared.
Correct. Don't we have a little rule that says if you see a log, make it an f of x? There's lots of little minor rules, but that's the one I'm using. And this one can be g of x. Then. So it's going to be f of x, which is that fella squared. Well, if you want to integrate x to the -3, you add 1 to the power and then you divide by the new power. Okay, subtract the integral. If you differentiate log x squared, you get 2 lots of log x times the derivative of log x times capital G, which is this guy. So that's f dashed of x, and this here is capital G of x. Let's make it look pretty. -1/2 natural log of x squared over x squared. That makes it look more like this guy. Take away. That's a negative, so is this, so I guess it's a plus now. The 2 and that cancel. That guy joins this guy, and now you have that one. Let's double check it. 2 negative, done. 2's cancelled, done. This guy joins this guy, -3, done. 1 log x, yep, done. So this is integration by parts done once. We still have to work on this guy, don't we? Who do we choose as our f of x?
ln of x.
Yep. And I'm just going to dot that one because it takes time, but it shouldn't be too hard to finish. So if you ever see a log somewhere in one of these questions, make that log your f of x. It's also the same rule as if you can't integrate it, make it your f of x. Well, I can't integrate log x, so that's another reason for calling log the f of x. The reason I chose this one is that it requires us to do a U sub. And it doesn't even look like it's a U sub. So this is a question where we're going to do a U sub first, and then we can do integration by parts. But this one is really sneaky because most U sub questions kind of look like they need a U sub, right? They just have a look where you can say, oh yeah, if U is equal to this, it'll probably become a bit nicer. This question does not look good, but it's going to become good. Oh, by the way, quite a lot of the questions have limits of integration. I'm not going to do that, but if we can integrate it, you can plug in pi and 0 yourself later. What I am going to do is find another way of writing this guy. The sine of 2t is a double angle. It can be written in a different way. Who are you?
Uh,
Come on,
Cosine,
keep-
cosine.
Is it sine
That's
of
the
t
one.
cosine?
Yep.
Oh,
Now, you probably don't need this bit, but I'm going to do it anyway. In my brain, it just looks funny. It looks much better that way around. Now, I said this is a U sub question, or at least it's a U sub question first. What's the U sub you should use in this question?
cosine.
Cosine X.
Okay. So you differentiate with respect to t, and you get negative sine t. You do the crossover. Then you isolate. Let's see what that looks like. Well, it's the integral of 2 sine t. That's a u. That's an e to the u. And the dt is negative 1 over sine t du. The signs cancel. And we have negative 2u e to the u du. Do you see that this integral has now transformed itself into this one? This guy is integration by parts. Who do you choose for the f this time?
Question: are we going to differentiate by parts while it's sub for U, or are we going to
Yeah.
translate it?
No,
Okay.
we're going to leave it like this and do integration by parts like this. And then once we get the answer, the u's are going to turn into cos t's and we're finished. So what would the f of u, I guess? What would the f in this question be?
EU.
Okay, let's see. There are a variety of rules. Isn't one of the rules that you should try and pick your f so it becomes simpler? Now, if I choose an f as e to the u, won't it just turn into e to the u and it really never went anywhere? So, who is the f going to be?
Negative 2U.
Now, if you pick the wrong one, it's not the end of the world. You should find out within a line or two after that this is not a good idea, in which case you throw that piece of paper away and you go back to this question and you pick the other one. So at least, I mean, it's not disastrous, but I mean, it's kind of frustrating if you do it too many times. You know, if you're always picking the wrong one. But I think what will probably happen is that after you've picked the wrong one a couple of times, you'll realize, okay, don't pick that one in this situation. It never works. Pick the other one to be F, and it does work. Now, at this point here, I'm just going to dot, dot, dot. Now, what's going to happen is you're going to get an answer in U's, agreed? And then turn all the U's into cosine T's and you're finished. Well, then you can worry about limits of integration.
Professor.
Yes.
If you were to take the integral of e to the u, but there was
Yeah.
a constant in the front, would it still just be like, would that be different from e to the u?
Well, if you did 2e to the u, the answer would just be 2e to the u. So
Oh, okay.
it doesn't change much. It's untouched. The
Okay.
2's still there, but it's just 2e to the u.
Okay, thank you.
Now, that one was an example of a U-sub that needed to be done. There's quite a lot of these U-sub partnering with integration by parts. This one here, for instance, is a U-sub. Now, see if that was just theta, it would be a straightforward integration by parts, and we would do this guy is F and that guy is G, and it would work. Right? So if it was 7 theta cubed cosine of theta, it would just be integration by parts. But it's not cosine of theta. It's cosine of theta squared. That means we have a U-sub. Now this U-sub, you have to trust the math, because superficially it looks like it's not going to work. But if you trust the math, I'll show you it does work. Who do you think the best candidate for a U-sub in this question is? Who do you think it should be in this situation?
Theta squared.
Good choice. Now, normally, would it not be 7 theta or something? It'd be a little bit clearer. Right now, that might not look like it's going to work, but let me take it to the end and show you it does. If you differentiate with respect to theta, you get 2 theta. If you do the crossover, you get that. And if you isolate the d theta, you get that. So this fella becomes 7 theta cubed, the cosine of u, 1 over 2 theta, d theta. And we got 7 halves, a theta squared, sorry, it's a u, a cosine of u du. Uh-oh, we've got an orphan left over. We have a theta squared left over, right? And we don't want thetas or theta squareds. We only want u's. What will the theta square get replaced by?
U.
Yeah. So what we have is this fella. Okay, you got a 50-50 chance here. Either that guy's F or this guy's F, right? Which one should be F so we can use integration by parts?
7 halves u.
Okay, that's the right one. And dot, 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 dot. And when you're finished, won't you have an answer with a whole load of u's in it? Turn all the u's into theta squareds, and you're finished. So things are getting a little bit more complex, aren't they? Instead of just having a integration by parts, and your job is to find the F and obviously the G, and just apply the process, maybe 2 or 3 times, it now becomes, hey, you may have to do a U-sub before you can even get to the point where integration by parts is going to work. And that U-sub might not be even that obvious. Are there any questions? I've been going through quite a lot. Do things have a flow to them? Do you feel you're on top of this? Okay. There's two questions. I think they're questions 16 and 17. Look something like this. And it's called a reduction formula. You don't need to worry about that. Essentially, you're being asked to use integration by parts once on this thing and see what it turns into. So as long as you think of the question as that and don't get caught up with what is a reduction formula, essentially what the question does is it gives you this guy and it gives you like 5 choices, only one of which is the right one. And we have to figure out what that is. So what makes it a little bit different? Do you see that guy up there isn't 2 or 3 or 42, it's an n. But I want you to think of it as if it was a 2 or a 3, because we're going to do the same thing. So I need to pick an F and I need to pick a G. There's one choice and that's the other choice, right? Which one's the F?
Ellen.
Yeah. The whole thing, in fact, right?
Yeah.
Yeah. And G is this guy. So we take the F guy. So we've got the natural log of x to the n. And you integrate this guy, you get 3x. Then you take away the integral. If you differentiate this one, right? Think of that as 3 or something. Don't you multiply by the power, reduce the power by 1, and then differentiate by the log of x. Are you all comfortable that this mess is what the derivative of that guy is? N times 1 less power times the derivative of log x. Multiplied by capital G, which is 3x dx. So this fella now becomes 3x, the natural log of x to the power of n. Take away that and that gets you 3n. That x and that x cancels. And ln of x to the n minus 1 dx. And one of the, I think it's 4 or 5 choices, will be the guy that looks like him. And that's the one you pick. You might wonder, why is it called a reduction formula? Well, see if you plug 5 in here. The answer becomes this guy to the 5, take away 3 times 5, this guy to the 4. And then you can use this guy and repeat it until it reduces down to nothing, and then you get the answer. I wouldn't suggest you do that. They take forever and a day, but it is possible. So the last one for this section that we're going to deal with is a very, very special method. If you ever see an exponential and a trig, so e to the 2 theta sine theta, e to the 5x cosine 3x, right? That kind of look. Then you're going to use this special method. It is integration by parts. It doesn't involve u subs or anything weird. It's only integration by parts. But nonetheless, it's going to be weird. Oops. I'm going to start by calling the answer I. So this fella here is I. That's not a biggie. Okay, now you need to pick an F and a G. I did give you yesterday the list that says if this ever happens, doesn't matter who you pick for F or G, both work. The only thing I ask you to do is make sure that you stick to who the F is all the way through the process. So for no particular reason except I want to, this is F and this is G. So let's see what we get. This guy is e to the 4 theta. If you integrate this fella, you get negative 1/5 the cosine of 5 theta. Take away the derivative of this guy is 4e to the 4 theta. The integral of this guy is negative 1/5 cosine of 5 theta d theta. And let's make it look slightly nicer. Two negatives make a plus. That's 4/5 e to the 4 theta cosine of 5 theta d theta. Have you noticed that this integral is just as ugly, if not slightly uglier, than the one we started with? Which makes you suspicious that I've chosen the wrong f or g. And for every other situation except this one, that's exactly what that is telling me. I chose the wrong f and g, right? In which case I would throw this away and I'd switch round, but not when there's an e in a trig. That's exactly what's going to happen. That's fine. What you have to do in this process, you have to use integration by parts twice. In other words, I'm going to do it again with this. And then there's a little kink in the tail, a little twist in the tail that gets us out of trouble. So this is going to be f, and this is going to be g. Do you see how I'm being consistent? Same kind of f each time. So it's going to be this fella. Okay, if we make this f, what we got? Leave this guy alone. And integrate this guy. Well, this guy, if you integrate it, you get positive 1/5 the sine of 5 theta. Take away the integral. If you differentiate this guy, you get 4/5 e to the 4 theta times another 4, which is where that 16 came from. With this guy. Just squeezed it in. So I have this fella. This and this gets me what? 4/25. Now I'm going to do something really sneaky here. 16/5 times a fifth is 16/25, and I'm going to pull that 16/25 out of the integral. So we've now done it twice. And in this process, when you've got these guys, you only do it twice, no more, no less. And you're going to say, I'm in the same blinking boat as I was at the start. It's just even uglier than it was. So here's the trick. Do you recognize this guy? It's that guy. And I called this guy I, didn't I? I said I is equal to this guy. So that means that I, the original I, is negative 1/5 e to the 4 theta, the cosine of 5 theta, plus 4/25 e to the 4 theta times the sine of 5 theta. Take away 16/25 I. Right, that's I, so 16/25 is 16/25 I. Where do I go now? Remember, the quest here is to find out what I is equal to exactly, right? What can I do next?
Just move it to the other side of the equation.
So I'll add 16 25ths to both sides. And that gets me 25 and 16. That gets me 41 fifths I is all of this. So how do I now get I? Almost there. What do I do to both sides to get I?
Multiplied by 5/41.
Right. Yeah, it's hard to say, but you're right. Right. Multiply by 5/41. I don't want to write that multiplication down, then the answer, so I'm going to do it both in one go, which is scary. But if you multiply this guy by 5/41, you get negative 1/41 e to the 4 theta, the cosine of 5 theta. If you multiply this fella by 5/41, you still got 5 in the bottom. You got 164, I believe, fifths e to the 4 theta, sine 5 theta, and add a c at the end. Whew. Now that is algebra magic. You start off with this guy, call it I, do integration by parts twice, and you'll end up with this. Add this guy to both sides, you now have that, and divide both sides by whatever this is, and you're done. I don't think it's elegant, but it's kind of sneaky, isn't it? That we now actually know what that guy is. I'm never going to do this, but I could prove it to you. Couldn't you differentiate this entire mess? And I bet you it's equal to that. I'm just not going to do it. Take me forever, but trust me, it works. And if somebody sticks a 0 to 2 pi there, don't you just plug in 0, plug in 2 pi, and do what you need to do. Are we good? Any question?
I have
Yes.
a question. I'm still trying to figure out where that 41 fifths came up. It's just that we just added all
Oh,
the
okay. Yeah.
fractions
What I
together.
did is I added this guy to that. So let's show you what that would look like. I had an I, and I added 16 25ths I. So can you think of that as being 1 plus 16 25ths I, which is 25th 25ths, add 16 25ths, which is 41 25ths.
Okay.
Right, so it's just a fraction thing. Any other points that we're not sure about?
Why does it say 41 over 5?
I thought we'd... Oh, shooting space. Should be 41 over 25, shouldn't it? Right? Easy fix. That's 25. Do what we said, but just have an extra 5. So that's 5 of this guy. And oh, God in Himmel, this one's actually going to be nicer, strangely enough. Because if you divide this one here by that guy, all you get is 4 on the top and 41 on the bottom. Huh, okay. 5 41s of this and 4 41s of that. The process was right. I just didn't add them together. Well, I did do the 41 bit, but I didn't do the 5. Any other points? That was just a mistake, but got it in time. Right, you're a lot of going to say hi for a few moments, and while you're doing that, it gives me a chance to get a quick intro to the next thing. We have a lot to cover, so we still have 7 minutes. I want to use it. So you all saying hi, I hope, while this is all happening. Okay. I've lost you. Oh, there you are. Gotcha. Section 7.2 is coming up. At least the intro. We'll definitely get our teeth into it tomorrow. What would you think is the hardest part of the algebra that we do? Well, I think a lot of you would probably say trig. Anything we trig is going to cause problems. Well, trig does not go away, and trig is here to stay, because 7.2 is all about trig integration. How to integrate functions that have sine, cosine, secant, squared, things like that. Well, there are a number of techniques. First technique is use identities to change the trig expression. And examples of that would be if you have to integrate something like sine squared x. Second very common method, use substitution. That would be for things like sine cubed x, cos squared x, dx. So there's your two main things in your toolbox. Identities to change the trig expression. So you can integrate things like sine squared x by using that method, and substitution, which you can use for things like this. Let's look at substitution. U sub, that's what I mean. Do not, these kinds of questions, these trig ones, do not use the whole thing as your U sub. So don't you make the U sub cos squared, and do not make the U sub sine cubed. They very, very rarely work. For your U sub, only use a single sine or a single cosine. Got that? Single sine or single cosine. So that is the problem. And which one you use isn't, well, it doesn't matter, they both work, though occasionally that is true. Very often one of them does the job and the other one just makes it worse. So it's a bit like integration by parts. If you pick the wrong one, you should pretty much know it's the wrong one early on. Hey, this one's not, nah, this is not working for me, right? But there are rules in which you can apply that will tell you the right one to use to save you having to spend a lot of time picking the wrong one. I mean, eventually you'll figure that. You'll figure the rules out yourself if you do enough of them, right? And you get enough of them where the first one didn't work and you had to use the other one. Right? But here is our first choice. It's really just a warm-up for tomorrow. What U sub should you choose, do you think? Sine or cosine? That's it. No other choices. Just sine x or cosine x. Probably a guess right now, and that's okay. So guess. If you get it right, I'll ask you why, and you'll say, I guessed. And if you get it wrong, I'll tell you the right one. So go for it. Who's going to guess?
Cosine.
Cosine.
Go for it. You actually, the cosine's the right one. Now, did you guess, or did you get an inkling why it might be the right one?
I guessed.
That's fair enough. So let me tell you the rule. If there's an odd power and an even power, right? In this case, the sine's odd and the cosine's even. But if there's an odd and an even, the U sub is whoever the even power is. And the reason why you choose the even power one is that won't it use up one of these guys and leave an even number of signs behind? And you think, well, what's the benefit of that? Let's show you. Let's get this guy out of the way first. If you differentiate a cosine, you get a negative sign. If you do the crossover, and then you isolate. Nothing remarkable about that. I have sine cubed x. This fella becomes u squared, and the dx becomes this guy. And we get a little bit cancelling. And you'll get that. That's pretty common. There's a sine squared left over, and that's typically a bad thing, not in this case. But I have to use trig identities to change the expression. In this case, I'm going to use that sine squared x can be changed into 1 minus cos squared x. And you say, well, where did that come from? I think everybody knows this one, right? Well, if you subtract cos squared from both sides, don't you get this guy? Now that means that isn't sine squared then 1 take away u squared, right? U is cosine, so 1 minus cos squared is 1 minus u squared. So this guy becomes negative 1 minus u squared du. Okay, we're pretty close to being finished. Is there anything I should do algebraically before I try and integrate this?
Expand it.
Okay, so that times that gets me negative u squared. That times that is positive u to the 4. You come happy about that? Distributed u squared essentially. Okay, power rule now. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And remember to return back to the x's. So negative 1/3 cos cubed x plus 1/5 cos to the 5x, add c, and we are done. So you might want to, for tomorrow, look up some trig identities that are likely to happen. So what ones are they going to be? You have to know what the double angle for sine 2x is and cosine 2x. We're going to use those. You're going to find that we're also going to use the half angle formula. That's cos squared x is a half 1 plus cosine 2x, for instance. Right? There's a half angle formula for sine squared. There's a half angle formula for cos squared. There's a double angle formula for sine 2x. there's a double angle formula for the cosine of 2x. You're also going to need to know that sine squared is 1 minus cos squared, and cos squared is 1 minus sine squared. And if that's not enough, you also need to know how secant squared and tan squared interact. So when we come tomorrow, we'll definitely use some, if not all, of those things I just mentioned. So that's a little bit of homework for you. Find your identities, have them all written in. I would write them all on one piece of paper. That way I just need to scan through them and see which one I'm probably going to use. And perfect timing. That is us. Bye-bye, guys. I'll hang about for a minute in case there's questions. We learned some cool stuff today. Emma, you do not seem to be agreeing with me today. We learned some cool stuff today. Okay,
Yes,
good.
yes, we did. And I'm so glad that you went over number 7 because I literally spent an hour and a half yesterday trying to do it.
Because it was good. Yeah, you're not the only one. Someone else mentioned that they were again. It looks like an infinite loop, doesn't it? Like it just keeps going forever. And it, now that you saw how it's done, apart from the fact I did a little mistake on the adding the fractions part, right? You kind of feel comfortable about how you would be able to do it now. Okay, that's good.
I was actually wondering if you could go over number 5 from the test.
Number 5 from the test. Do you have it handy, or it'll save me looking it up?
I have it.
Okay. Oh, you haven't, or you do?
I do have it.
Perfect. You get it for me.
Okay. So it's the y equals 3x squared, and then y equals 18x minus 6x squared. And we're using the shell method, and we're revolving about the y-axis.
Gotcha. So when you do the shell method, oh, I'll switch over to the screen. When you do the shell method revolving around the y-axis, do things need to be in x's or y's?
X's.
That's it. I guess I should have these two things sketched. So I'm going to have to go out and I'll go into Desmos. Actually, I should be able to do them on my calculator. That's quicker. So let me change what I was about to do. And I need it for a couple of reasons. One is I need to visualize what this darn thing looks like. And secondly, one, I need to know the start and finish x values. Right?
Yes.
So we're going in here, switch it on, clear that out. Go in here, clear out the old stuff. Don't know what that's doing there. Right, so 3x squared. And the other guy is going to be 18x. Oh, darn it, 18. Oh, there we go. 18x. Take away 6x squared. Have no idea what the window looks like, so I'm going to go -3 as a start value, and then I'll tweak it if I need to. So it goes like this. Okay, it looks like it's this tiny little banana to the right, isn't it?
Mm-hmm.
So that means I can adjust my window saying -1 to 3 and then try it again. That might help. Perfect. Okay, so I'm just going to do a little sketch of what that looks like. It basically has a guy going like this and a guy going like that. And this is the 3x squared guy. And this is the 18x take away 6x guy. And I'm pretty sure that's 0. And I just need to know that guy, right?
Mm-hmm.
Probably could just do intersection on that. If it's a nice number, I won't need to do algebra. So I'll move up here. First curve, second curve, guess. And it's a nice number, it's 2. So I got everything I need. It's the integral from 0 to 2 2 pi radius height, x. So it's integral from 0 to 2 pi. When you rotate about the y-axis, your rectangle that we're talking about is typically a guy that looks like this. And that distance from here to here is radius, which in this case is just x. And the height is the top, take away the bottom. In other words, this guy, because he's higher up, take away that. So it's going to be 18x, take away 6x squared, which is the top one, subtract the bottom, which is 3x squared, dx. Did you do that bit right, as far as you can recollect?
No.
Was this the bit that was getting you? The
Yeah.
setup? Right.
I just don't understand the reasoning of it. I don't know why.
Basically, the formula says that if you take this little guy and you rotate it about the axis, what you end up making is a little baby shell that looks like this, right?
Yeah.
And then if you move that rectangle around, you make other little shells. That's why they call it shell method. But the volume of all those shells added up is the rotation volume, right? The volume of the shape you're trying to get. So all those little tin cans, one on top of the other, right? One inside the other, if you did enough of them, would actually generate the volume that you're after. Now, how do I find the volume of one of these? Well, can you imagine you split it and you opened it up? You'd have a long little fella that looks something like this, wouldn't you?
Mm-hmm.
Now, the thickness of it is the delta x part, which is this guy. That distance from here to here, is it not the circumference? And in this case, the radius is x, so won't that get you 2 pi, the radius, 2 pi x? And what's the height of this fella going to be? Well, the height of this fella is the height of that rectangle. And that rectangle is from there to there, which is what this guy is,
Mm-hmm.
take away from there to there, which is what this guy is. So that's what the height is represented by. So all the pieces do fit together. So as far as you're concerned, then, if you want to be able to do this, you need to be able to identify those two things. As long as you can figure out who those are, you're going to get the answer. So let's just continue just a little bit further. That and that combined, you now have 18x take away 9x squared. Probably pull out the 2 pi. Okay. What do you think I'm going to do about this and this?
Multiply it through.
Right. So all you need to then do is the power rule and you're finished.
Yeah.
So I'm trying to get my head around what you're having difficulty doing.
It's just identifying the radius. I identified the height, right?
Okay, so the height's not your issue. The radius is the distance from that rectangle to the axis of rotation. So let's just imagine that we took that shape and we moved the axis of rotation. So instead of being the y-axis, let's put it way over here at x equals 10, right? For instance.
Okay.
So you got the shape that looks like this, and you're quite happy with the height thing, so I'm not even going to talk about the height thing. Now, what you got to imagine is, where does this thing live? This distance here is x. And sometimes that distance is the radius, especially if you're rotating about the y-axis. But the radius is the distance from that rectangle to wherever the axis of rotation is. So how do I find the radius this time? Well, I know that that distance from there to there is 10. I know that this distance from here to here is x, because it's always x. So won't the radius be
10 minus x.
10 minus x. So you'd go over here, and that would become a 10 minus x. The height's the same, it doesn't change, but the radius does. Depends on axis of rotation, right? That can be different, right? So that would be 10 minus x. So wouldn't you have a 10 minus x and a FOIL going on and then power rule as before? Now what would happen? Yes?
Would it be safe to say that if you're doing the shell method and we're rotating about the y-axis or something parallel to the y-axis, it would always be just an x. It wouldn't be like x squared or x cubed.
Will never be an x squared or an x cubed. It will also have always have an x in it. But you see in this second example, wouldn't the radius be a 10 minus x?
Yeah.
So it would be 2 pi 10 minus x times, you know, the height guy, right?
Sure.
Now, suppose it was over here at x equals -3,
It'd be
Right.
actually
right? So the radius is that distance, right? What would the radius be this time?
x plus 3.
Yep.
No.
Yeah, you were right. Or 3 plus x if you want. Now, you might say, well, how do I do that? Well, isn't the distance from here to here 3, and isn't the distance from here to here x? So won't the radius be 3 plus x?
Okay.
Right? So your job is to find the distance from the rectangle to the axis of rotation. In this case, it's going to be just an x. Could be x on its own, could be x plus 3, could be 10 take away x, but only an x. No x squareds, no x cubes. That ain't going to happen.